Hello everyone, I welcome you all in the next lecture of 12th NCERT Mathematics. In this video lecture, I'll discuss question number 12 of exercise 1.1. First of all, I will write key points of the question number 12 and then I will start the question. Okay, so in question number 12, they said that show that the relation R defined in the set A of all triangle. That means A is the collection of all the triangles. All the triangles. Triangle shape we already know. This is like that. A, B and C, which is a closed figure, okay, and have three sides, three vertices and three angles. Now, let us set A and relation R define on A like T1, T2 belongs to R if and only if what we have T1 is similar to T2. Okay, T1 is similar to T2. So first of all, recall something. When we say two triangles are similar, T1 is similar to T2. Okay, suppose T1 is A, B, C and T2 is P, Q, R, and if we have AB upon PQ equals to BC upon QR equals to AC upon PR. Then we can say the triangle is similar. It means what it implies? It implies that we say two triangles are similar if their corresponding sides are proportional. If corresponding sides are proportional, or we can say corresponding angles are proportional. By both the things we can prove that triangles are similar. Okay, that is a concept. When two triangles are similar, then their sides are in proportion or their angles are in proportion. Okay. Now, start the question. For reflexive, let T belongs to A. That means T is any triangle. Okay. Clearly, every triangle is similar to itself. So implies that T is similar to A. T is similar to T. Why so? Because you can observe now. Suppose T is like that. A, B, C, and also same triangle, dicto. A, B, C. So AB upon AB, AC upon AC, BC upon BC have ratio 1, and as they are in same proportion, so we can say yeah. So implies T comma T belongs to R. It means every element of A related to itself, hence R is reflexive. R is reflexive on A. Okay. Now for symmetric. For symmetric, we have let T1 comma T2 belongs to set A. With one more thing we need to assume, T1 comma T2, ordered pair T1 comma T2 belongs to set relation R. Okay, what it implies? This thing implies that T1 is similar to T2. Okay, if T1 is similar to T2, then what we can imply is their corresponding sides are in same proportion, are proportional. We can say their corresponding sides are proportional. Okay, or we can say one more thing we can say here from above line. T1 and sides of T1 and sides of T1 and T2 are proportional, corresponding sides. Corresponding sides of T1 and T2 are proportional. Okay, so it implies that corresponding sides of T2 and T1 are also proportional. What we can write? Corresponding sides of T2 and T1 are proportional also, hence implies that T2 is similar to T1, implies that T2 comma T1 belongs to relation R. Okay, so it implies that R is symmetric. R is symmetric on A. Okay, now clearly for transitivity also, for transitive. Okay, for transitive means let T1, T2 and T3 belongs to A, with one more thing we need, two more thing we need to assume. T1 comma T2 belongs to relation R, and T2 comma T3 belongs to relation R. We need to check is T1 comma T3 belongs to relation R. See, as T1 is similar to T2 and T2 is similar to T3, it implies that, what it implies? Corresponding sides of T1 and T2 are proportional. Okay, same thing for this one. Corresponding sides are proportional. Corresponding sides are proportional for T2 and T3. From both the things we can imply that corresponding sides of T1 and T3 are also proportional. Why so? because reason is T1 is similar to T2, T2 is similar to T3, T1 is similar to T3 because why so? What it implies? T1 is similar to T3 because above thing actually implies corresponding sides of corresponding sides of T1, T2 and T3 if we are taking one at a time. Okay, if we are taking two at a time are in, I think there is no need of writing this one. Okay, this line is sufficient, this line is sufficient for them. Okay, so T1 is similar to T3, T1 is similar to T3, hence it implies T1 comma T3 belongs to relation R, implies R is transitive on A. Okay, so it implies that, what it implies? R is an equivalence relation on A. R is an equivalence relation on A. Okay, done. Now next thing is what we need to prove. Next thing, the first thing is equivalence relation. Second thing is they ask that T1 we have, T2 we have, T3 we have, three triangle we have with their sides. Okay, and they ask which one of them is related to each other. Okay, B part of this question is they give T1 with sides, I'll make here A, B, C, and the sides are 3, 4, 5. T2 triangle is P, Q, R, and sides are 5, 12, and 13. Okay, this one also you can take here 5, 3, 4, 5. T3. T3 is D, E, F, I assume, and it will be 6, 8, and 10. Now, here you can observe that, recall the definition of similarity. Is T1 is similar to T2? Is T1 is similar to T2? First of all, we need to check. Is T2 is similar to T3? We need to check. Is T1 is similar to T3? We need to check. Okay, and if either one of them is true, then they are related to each other. Okay, so observe that. Clearly we can observe that T1 and T2 are not similar to each other. Why so? Because the proportion of the sides, if we are taking AB upon PQ, AC upon PR, and BC upon QR. Okay, and suppose we are taking for T1 and T2, for T1 and T2, AB upon PQ ratio is 3 by 5. What will be 3 by 5? Okay, and AB upon PQ, AC upon PR ratio is 4 upon 12. In simple it will be 1 upon 3. Okay, and the third ratio is BC upon QR, 5 upon 13. Okay, this is the first type. This is the first case we took, that AB upon PQ. In second case, you can take AB upon PR, AB, this AB, this AB and PR we can take, okay, and then we can make. In this manner, if we are checking, that's your homework, okay, you need to check. Second one case, okay, and that's the first case, second case, and the third case is with this AB, this QR, and then different cases, okay. So we can check all the cases. In all the cases, it is not similar, okay. So clearly, from all these cases, you need to check, okay, T1 is not similar to T2, okay. Similarly, T2 is not similar to T3, but now I'll show you something. T1 for T1 and T3, observe that. If I'm taking AB upon DE, that is 3 upon 6, AC upon DF, that is 4 upon 8, and BC upon EF, that is 5 upon 10. What we have? See here, AB upon DE, okay, AB upon D, that is 3 upon 6. I'll check. AB upon DE, yeah. Then AC upon DF, this is 1 by 2. Then AC upon DF, 4 upon 8, that is also 1 by 2. And at the end, BC upon EF, I think, yeah, BC upon EF. BC upon EF, that is what we have, 5 upon 10, that is also 1 by 2. So it implies that AB upon DE equals to AC upon DF equals to BC upon EF 1 by 2. It means the sides are proportional. So it implies that T1 is similar to T3. Okay. So it means that T1 is related to T3. Okay. Understand? I think you got to this point. Okay. So if you have any doubt, you can do comments. Thank you for watching.